Okay, excellent. Welcome, everybody. I think we are, many people, which is good. This is the very first session on Zero OS. It's basically the kickoff session on what we call the EAP, so the Early Adopters Program. This is the very first time we do this. Most probably we will make mistakes, we will have problems. But the most important point I want to make is that this is a platform where we ask questions, where we interchange information, where we make mistakes. I also hope that people will do hands-on things during the session. And you should see these sessions as like sync moments. So we'll always do a demo of 15 minutes or 20 minutes, sometimes half an hour. But most importantly, the idea is that you do the same demos, even and by preference during the sessions, and after the session and before the sessions, and that you use this platform, this like 2 weekly, it's a bi-weekly, no, it's twice per week sync moment sessions, and that we use these sessions to basically ask questions and exchange basically knowledge and insights. So what we will cover today, so once again, this is the kickoff session. That doesn't mean that you won't see anything interesting. You will certainly see interesting things. I will do some demos that you will love to do yourself. But at the end of the day, this is just the kickoff session. So this session is to make sure that we all understand what this is about, what we try to achieve through the EAP, and that you know what to do to get 100% involved in everything that we will do next. So what we will do today, first of all, I will discuss once more, if it was not already clear from the invitation, what the EAP is, the Early Adopters Program is, what the schedule is, and what you can support through this program. We will, of course, discuss Zero OS. What is Zero OS, and how should we understand it? How should we position it? And most of us, certainly, we know very well already what Zero OS is, or think we know what it is. See this as an exercise to position Zero OS, because that's certainly also something we all need to learn to do, is what is the elevator pitch with Zero OS, and how do you talk about it? That's certainly, in a way, the very first time we do this exercise. Then we will walk you through to all the GitHub repositories which are involved in Zero OS, which are quite a few. And as you will see, it's quite interesting to understand the structure of the repositories in order to also find the documentation and get started with everything. Then we do an actual demo. And again, I invite you to do the same thing, probably not today, but as a follow-up, not during the session, but as a follow-up to the session, I really recommend doing exactly the same thing that I will demo you. And we will basically boot a Zero OS on VirtualBox, and then we will interact with it through a Python client. We will actually, do a few things. I have a few scenarios in my head. One of them is basically create a RAID 0 disk on it, and you'll see. It will be quite interesting. And then important for all next sessions is that you prepare with a Jumpscale 9 Docker container, because for all next sessions we will be using this Docker container for basically creating the cluster, for creating more sophisticated things that you can do without it. So that's quite important. Okay. The intro. So once again, the whole idea of the Early Adopters Program is that we provide valued partners and believers in our purpose, that we really want to create a new green, neutral, secure internet, and we want to provide you as a valued partner, and you, most of you are of course colleagues, but clearly this kind of session we will repeat many times for other people, third parties, customers that we choose to give access to the basically ZeroS early adopters program. So most importantly, what we will provide is all insights. We'll give support to all the people involved in this program. There will be a technical support forum. Well, when I say technical support forum, today, well, this is basically that we contact each other, that we use Telegram. But what we will have quite soon is a real forum online, an online forum that is nicely integrated with Issue.online, where people can, first of all, ask questions, but where we also create like a wiki where we will create a frequently asked questions section, kind of documentation pointers, so that people easily find back information based on questions other people already asked. Mm-hmm. And then, of course, we have this, what we call the unique training program, for which I have the next slide, where we will have these sync moment sessions. You could call it a training program, but I rather love to talk about sync sessions, where we'll do always short demos, discussing one specific aspect of the whole solution. But most of the time, I'm hoping to get questions based on what I show or what you try yourself. You can also expect us creating all kinds of more specific sessions going forward. For instance, create a session on, for instance, building ZeroS. How do you compile it? How do you do the configuration? We will create more specialized sessions on topics like virtual machines, very specific. So what you see here, that's what we have planned, and that's also the dates we foresee. For today, it's the kickoff. And then, which is kind of strange, maybe is the next session is on Thursday, but as you can see on Thursday, we plan to do the booting ZeroS and playing with APIs, which I will actually also cover today. Now that's on purpose. The idea is that I show it today and that we do it again on Thursday, but you will do it again. So there it's really the point that we will collaborate a bit and that each of you is able to do exactly the same thing. And I will use that platform to show you other examples than the ones that I've prepared for today. Then next week on Tuesday and the next week on Thursday, we also have again a session which is more specific to containers and creating containers and starting containers based on this concept we call the FLISTs, where we'll learn you how to create a FLIST. It's about, as I will discuss in a minute, about the ZeroS unified file system that we will show you, the ZeroFS. I'll explain that, I will demonstrate it, I will make sure that you know how to work with it, how to create them, how to merge lists and things like that. And then on Thursday, then the real exciting stuff starts. We will start creating a cluster, really having multiple ZeroS nodes working together and interacting with them through the orchestrator, as we call it, API. And that's really the basis of creating a real platform for running virtual machines, booting virtual machines, creating boot disks, which is more the topic of the week after, July the 4th and the 6th, where we will actually play with virtual machines. And on July the 6th, we will do, well, which is quite exciting, we will really run OpenVCloud on top of a ZeroS cluster. So basically, this will allow you to use your existing OpenVCloud portal environment. It will allow you to use the RESTful APIs, even of OpenVCloud, for running, for instance, a cloud space in and a virtual machine, but then on a ZeroS nodes, which is quite exciting. The last two sessions is more related to at your service, where we will make sure that people know how to work with at your service, which is a session we already did in the past, but this time we will redo the session more specific to an environment running on OpenVCloud. Well, OpenVCloud running on ZeroS, and I will show you how you can basically automate a lot of things, workloads basically running on a ZeroS cluster to at your service. The last session is really what many people have been asking for since a long time, is where I learn you how to create your own at your service templates. and how you can leverage downscale to really, for instance, create your own very custom-made at your service template, including monitoring for and self-healing if you want to. So that's really a very exciting topic that people, including myself, have been waiting for since a long time. So that's a big challenge also for me to bring this session, but I'm really, really eager to deliver it. Okay, what is ZeroOS? What to expect? It's a code that's an error. I should have put something else. Let's put here the elevator pitch. Elevator pitch. And you know what? I don't have the elevator pitch. I'm still thinking of what the elevator pitch should be. So let me immediately switch to slides. And this is the definition of ZeroOS. And please challenge me, challenge yourself, challenge the colleagues with the question: is this a good definition? Is this really covering everything we try to achieve with ZeroOS? Because ZeroOS, as it's stated here, is a stateless and lightweight Linux operating system, designed for cluster deployment. So you typically use this operating system to deploy not just on one single node. You typically deploy it on multiple nodes, which form then the ZeroOS cluster. And this ZeroOS cluster is then meant to host containerized applications. So basically containers and virtual machines. So both containerized applications and virtual machines. The point here that is highlighted is that it's a stateless and a lightweight operating system. The talking points about this is quite clear. Lightweight means it's an operating system, not like Ubuntu, which is a general purpose operating system. No, it's a single purpose operating system that allows you to securely run and host basically containerized application and virtual machines. And it is really optimized to do just that. It doesn't contain anything else than what you need for running containers and virtual machines. And from a security perspective, this is already interesting to highlight because the attack surface is much smaller than what you have with a general purpose operating system. So for instance, something I like to highlight is you cannot SSH into a ZeroOS. If you want to SSH into a ZeroOS, you can of course install the daemon to do so, but by default it doesn't include anything. You have to install it if you would want to do it, but it's certainly not what you typically would want to achieve. And stateless is probably the most interesting point, especially if you start comparing it with other solutions in this context that are trying to do the same thing. Stateless means it is basically not saving anything to a hard disk, not even system files. The point is also that the idea with the ZeroOS cluster is that when you lose any of your nodes in a cluster, is that it should not be a problem. Any workload running on that ZeroOS node should easily be restarted on any other node in the cluster without the user feeling it. Because also the state specific to that workload or to these workloads running on that ZeroOS node is not really kept on hard disk of that node. It's something that needs to live like in the cluster. I always compare with like how our brains work. When you have a car accident, I hope you never have a car accident, but what you typically hear from people having a car accident is that they forget a lot of things, but after a while things come back. They seem to remember things after a while when they have recovered. And that's also how we see a ZeroOS operating system or a cluster of ZeroOS nodes, is that they work all together, and if one of the cells, one of the nodes dies, that should not necessarily be a problem. So the whole cluster should recover from it, because none of the cells is like stateful. It can die, a cell can die, but the workloads, the memory is like distributed. It's like held by the cluster, not by a single node. That's the point I have to make. You need to make our own stories. We need to challenge each other. You need to challenge me on how we define Zero OS. It will be an important thing because people will want to understand what is so different about Zero OS. For instance, if you compare it with container Linux from CoreOS, and because that's certainly kind of a competitor in that space. Now, this is also an interesting slide I love to include when talking about Zero OS. So you take one step back, explaining what the design goals were or the design principles. I like this slide. It took us quite some time to create it, to think about it, and again, think about it yourself. So maybe again, it doesn't well cover everything we want to say. I think so it does today, but still we should challenge each other. This basically is a very important message. It talks about what we try to achieve. So the big points are: it's designed for the edge. It's designed to be a truly utility OS, and what I mean with true utility, if you compare it with the general purpose, and true utility. Think also about electricity grids. It's utility, and it's really it's all about green, about energy efficient operating system, or also more importantly, creating energy efficient distributed data centers based on Zero OS nodes forming a cluster. The first one, when we talk about the edge, it is meant to run as close as possible to the end user. So the edge is quite clear in what it means. And then for each of these big points, we make then more specific explanation on what we mean. And deploy anywhere. So Zero OS can be run on any small or big server node close to the end user, taking out the dependencies of long distance connectivity to large remote data centers. So the idea is really that you really deploy it anywhere. You could deploy, as I will do, on a virtual machine, on virtual box. It could be deployed on small boxes as we will make them available. It could be deployed on let's call them G8 environments or G8 systems as we used to do. And as we certainly will continue to do for creating larger nodes or larger grids. So it's meant, and that's where it is kind of different if you compare it with our previous solution. And I mean the stack, as I will discuss it in a moment. It could not be deployed anywhere. This thing can be deployed anywhere. So the operating system, including all components coming on top of it, could be deployed even in a virtual environment on your own personal computer if you want to do so. A very important point, of course, it's grid aware. Remember that in the definition that Zero OS is an operating system designed, basically meant to be deployed in a cluster. So typically you will not just run it on one node, you will run it on multiple nodes, and these nodes will form a cluster. And the operating system is, from that perspective, very grid aware. He will look to find his peers. He will look to find his buddies to create one single logical compute and storage capacity environment. Once again, there is no local storage or file system files or system files. This comes back to the point I made before, that it's a stateless operating system. Meaning that you typically don't store information only, let's say, on specific nodes. You will store it on, well, as you will see in one of my next slides, in a very distributed way, because clusters, well, a cluster is formed by nodes, and all these nodes work together to make sure that information is distributed, stored, and workloads are also distributed, stored on the cluster, and not on specific file systems of specific nodes. And of course, as we know, we are very in love with everything related to Git servers, and everything is controlled to a version control system, a Git server. It could be GitHub, and we leverage that a lot for everything we do in how we create software, and that's a very important point. in our design. A true utility OS is about making sure that we have a solution that doesn't require a lot of training, that it's very clear on how to use it. It's quite straightforward. Like electricity, you need electricity, you get electricity just by plugging into the socket in the wall, and you know how to use it, and it should be simple. And that's also the principle we always have in mind when creating such an environment, when creating an operating system to be deployed in a cluster for hosting containerized applications. It should be really, really like energy, really simple. It should not, but also remember the point here is that by creating an environment which is really simple to use, self-healing is an important thing there, is that it doesn't require, let's say, human interaction to solve problems. That's an important point. Many things, like electricity, you don't have to think a lot. It's not like you have to configure a lot. If you think about a general purpose operating system, you typically have to do a lot of configuration. You have to think about many things, deactivate things, activate things, configure things. Here we really try to keep things as simple as possible. And those things that might need follow-up should be monitored by the at your service solution we bring as part of the bigger story to make things heal automatically by the system. Just as what you experience from energy or electricity, you don't bother too much about the inner workings or what happens in the back end. You just know it works. Or like the phone, I always like to point to the touch tone. You know, when you pick up the phone, you always hear the touch tone. You always hear the telephone, and it just works. It's always on and shared. It's really designed. And once again, I repeat, not to run somewhere in a corner just to be used by yourself. You could, of course, do that, but it's really designed for sharing its resources into the grid or into the cluster. And again, you have the choice not to do so, because if you deploy a ZeroOS operating system on a node, you're of course in charge of what will happen. But the whole idea of ZeroOS is to create a cluster. And the whole idea of creating a cluster is that you share capacity. And that goes in two directions. That means that the spare capacity that basically you are not using can be made available to other users, to other workloads basically in the cluster. And if you need more capacity, you can use that capacity from within the cluster. That's really the basic idea. And then green, of course, don't forget that we are a company that always tries to eliminate layers. And that's actually also what we also do with already ZeroOS. It's a lightweight operating system, really focused, not as a general purpose operating system, but focused on making sure you have a very secure platform for running exactly what you want to run, namely virtual machines and containerized applications in a distributed data center. And we do that by eliminating everything you don't need to attain that, and making it less is more operating system. By design, this means there is less maintenance, because there are less what I love to call moving parts, meaning less things that can go wrong, less things where humans can do stupid things, and we really count on what we achieve through at your service. That through self-healing, a lot of things can be solved automatically. I think again about the brain. If something is stored in your brain, it is not stored on a specific location in your brain. Like I can kill that single cell and I know that I forget my telephone number. That doesn't work like that. It is stored everywhere, and there is some self-healing thing in our head that makes sure that when that cell dies, that is also storing part of your telephone number, let's say, that automatically another cell takes over to do the work. And it's about maximum performance. It's all related, of course, to this green thing, is that we make sure that you really have your hardware, you really have your the potential of your hardware, and we make sure that we can get the maximum out of it by re-leveraging all APIs, all possible new APIs that allow us to go as close to the metal as possible. See, so it's a lot of talking, and I invite you to challenge again this message. This is a little bit of marketing, but it's important. Everybody, each one of us, when at a party, when in an elevator, you should be able to talk about it confidently. No, what's the word? Huh?
That's correct.
Yeah.
Confident.
Yeah, yeah, and
with confidence.
Yeah, with confidence. Okay. I created this slide like 2 days ago because to me it's a good elevator pitch to people that know OpenV Cloud. How does this relate to OpenV Cloud? And I always tell them, you know what, if you think today about what we do with OpenV Cloud, we typically, both on the storage nodes and on the CPU nodes, we install Ubuntu. Ubuntu general purpose operating system, and on top of that, for doing the block storage, we leverage OpenV storage software from our friends. That's what we do, that's what we know how to do very well, and that's what we have been doing at many of our customers until now, and we will probably continue to do for a while going forward. And on top of that, we have OpenV Cloud, and we use at your service basically to automate stuff, to do the monitoring, to do the self-healing, and so on. That's the story. Now, what we are actually doing, we are replacing Ubuntu by ZeroOS. So we make sure that we don't need to deploy any Ubuntu general purpose operating system. We just deploy our own operating system and making sure it's really doing only the things we want to do, and we do not have all the rest on the hardware. On top of that, we replace OpenV storage with the ZeroOS block storage, and what we call ZeroOS block storage I'll discuss at length in next sessions. But remember, and I will show that also in the next slide, that block storage or the components that enable block storage in a cluster of ZeroOS nodes is basically also just another workload that you deploy on a ZeroOS cluster. So just as any other workload you can think of, like S3 or a NAS server or a web server or a CRM application, or name whatever you think of, is a workload. And indeed also block storage, or providing block storage that you typically need for running virtual machines. Well, block storage is enabled through components that we also will discuss in a minute, that you deploy on a ZeroOS cluster. Now, an important point about this slide towards our partners, of course, is that OpenV Cloud and Atlas Service basically don't change. We basically port at the level of OpenV Cloud the system from working on top of Ubuntu OpenV storage to working with a ZeroOS cluster. And the storage we create based on ZeroOS. So from that perspective, people, so end users, for instance, or operators using the Cloud Broker Portal, or people using the Cloud APIs or the Cloud Broker Portal APIs, they should be able to do whatever they did until now. Nothing would change. And the same thing goes about Atlas Service, and especially the Atlas Service RESTful API, that for instance, the people from Artilium use for creating the e-portal. So they send blueprints to the Atlas Service level, and Atlas Service then talks to OpenV Cloud. Well, from that perspective, nothing should change. They should not even be aware that underneath we are not using OpenV storage or Ubuntu, but we are using ZeroOS flavors. So that's the whole idea of what we are doing right now. Huh? I think it's, yep. Yeah, she can. Yeah, go ahead. Yeah. No, this slide, don't get confused about it. I will discuss this slide at length, and I'm building a version of this slide, a built version, that shows you step by step what we will do in all the next sessions. What this slide shows, in a nutshell, it shows you basically an example of a cluster with 1, 2, 3, 4, 5 nodes. And on that, so the very first thing you typically do, you first create a zero-tier network. Zero-tier network is certainly something we need to discuss. Zero-tier network, for some of us, it might be a new thing. It's what we use today more and more, especially for having a very easy to use management network. And that's what you see here. So we typically start by creating a zero-tier network somewhere, and I'll show that in the demo. And then you have what we call the orchestrator. The orchestrator is basically one of the very first things you install. You could install it in a Docker container. You could even run it, why not, on Amazon if you really wish to do so. You could run it anywhere. And the orchestrator, as the word says, is basically a piece of software that orchestrates that allows you to interact with REST APIs, for instance, to orchestrate a cluster of Zero-OS nodes. So that's where you typically start. You deploy somewhere an orchestrator. This orchestrator then needs to be made aware of the nodes. And once it has awareness of the nodes, it can orchestrate things that happen there. So through the orchestrator, we'll show that in the next sessions. You can, for instance, then deploy a virtual machine, or you can create a private network and stuff like that. Everything through very easy to use APIs. And it's clearly there, and maybe I should add that to the picture. It's clearly there on top of this orchestrator that you will have the interaction from OpenVCloud. So OpenVCloud will typically talk through the orchestrator in order to get things done on a Zero-OS cluster. You also see here an Azure server. Azure Service Server is basically a very important part of the solution. The Azure Service Server and the orchestrator clearly have to work together to do the deployment and the full lifecycle management of the whole environment. So not just of the infrastructure, but also of all the workloads that you have. So the Azure Service Server is both responsible for, well, basically monitoring the Zero-OS cluster infrastructure and making sure that self-healing takes place. But the same environment, the same Azure Service Server is responsible for making sure that all workloads from customers, for instance, or infrastructural workloads are being monitored and auto-scaled and auto-healed by the engine. Yeah, and again, the orchestrator is typically the thing that you use to do the basic provisioning things and so on. Good. Now, next, I won't discuss all of this. To the right, I show you that you typically, when you deploy Zero-OS on, let's say, a classical G8 environment and hardware environment, you will still have a 1 gigabyte Ethernet management network, and you will also still have, for the storage, a low latency, high performance 40 gigabit Ethernet backplane network. Now, these are, of course, optional. What I mean with optional, you can basically perfectly create a cluster of Zero-OS nodes, which are running, well, really distributed somewhere in the internet and only connected through the zero-tier management network. And in a way, it would certainly work. But clearly, if you want to have a very performant environment, as we typically deploy in data centers, you will, of course, use for the storage a very performant backend network. And of course, for the management, as we used to do, we'll use a 1 gigabit Ethernet backend network too. I'm getting questions here. Let me check. Yeah, good point. Sorry for not doing so. So let's do a full screen like this. Voila, it's better. Sorry for that. Yeah.
Thank you, Dima.
Yeah. So see, and this is then the the backend, so it's optional, but typically for the typical deployments we do, it's certainly something that is important. And then you see, don't get confused too much. And then you see basically workloads, because everything you see here is like something you deploy, you know? And you can see that everything we deploy are containers. It's all about containers. Everything is a container. Now, the actual workload that is shown here is like, it's not, well, how to say it, if you deploy a cluster, the standard cluster does not have any workload. But the very first workload you typically will deploy on a ZeroS cluster is what the thing that you need, remember, for running virtual machines, meaning you need block storage. You need, remember in my slide, you need indeed the ZeroS block storage. And that's actually what is being shown here in the slide. And again, it's important to know, deploying the block storage, we'll do that later in other sessions, is done through the orchestrator. So the orchestrator has a very nice, easy to use RESTful API that allows you basically to deploy the block storage infrastructure. Yeah? And of course, also everything you need, for instance, to create a virtual disk. Now, just high level, how does it work? You typically have per virtual machine. So here we see multiple virtual machines, and this is basically a workload. Somebody needs a virtual machine. And per virtual machine, we typically have what we call an NBD container. And the NBD container is basically the block storage server. So that is the thing that the virtual machine uses for having all his virtual disks. So per virtual machine, you have one NBD container servicing the virtual disks to the virtual machine. Yeah? Now, this container per virtual machine typically needs two things. First of all, it needs an SSD-based storage cluster, and it needs a T-log container, and the T-log container on its own needs an SSD storage cluster. So basically, all these containers are about storage clusters. You have a primary SSD storage cluster and a backup SSD storage cluster. And then for the T-log server, transaction log server, which is also running in a container, you have indeed a storage cluster based on HDD. So you certainly recognize this a little bit from what we know about Open vStorage. So it's basically a little bit the same concepts. And what you also see is these RDB containers. And a cluster typically is basically a cluster of RDB servers. RDB is a key value store on disk that we leverage for basically creating the storage clusters. And what it is shown here, that on each node in a cluster, you will run multiple RDB containers, and multiple RDB containers on multiple nodes together then create what we call such a storage cluster. You can create that on HDDs and on SSDs for doing so. I'm not going to elaborate more on this today. Just know that that's probably the more exciting stuff when you start using all this. It's part of one of the next sessions. Yeah. Now, this is quite important, of course, to fully understand and to find your way in the documentation and in the code, if you are interested in seeing the code, is the GitHub repositories. And maybe the best thing I could do is use the browser, of course. We go here to GitHub, because that's where it is. We go to GitHub, and there you go to ZeroS. That's basically the place where you need to go. Everything is there. You will see you have several repositories here, and I'll discuss each of them a little bit. And the main repository is the home repository, which is seen here. The home repository, in a way, doesn't contain any code, any implementation code, but it's like the place where we try to bring together all documentation, and it's like the place to start when getting acquainted with the Zero OS. For instance, apart from the screenshot, you'll get here the same overview that I had on my slides. You'll also see release information, quite important if you want to understand. Let me show you, for instance. We are currently working and releasing the Alpha 4 version. You can click on it, and then you see exactly where we are, what we are doing, and what you can expect from the Alpha 4 release. And I'm not going to discuss this, but this is always very specific and also always very interesting for you, I think, to clearly understand how this works. One of them is, for instance, that at your service, the itch.online integration is taking place right now. So the REST APIs exposed by the orchestrator will be protected through itch.online, as you would, of course, expect, and that is what we are actually delivering right now. So this is quite important that you see the release schedule, have details about the release schedule, and then you have the actual repositories. Now, before I go to the actual repositories, as you know, I'm most of my time working on the documentation, and what you will see is that in every repository there is a docs directory, and everyone. In the one of the home repository, we try to create one place from which you can then jump to the other repositories. See, it gives you the same explanation as I used in my slides. There is always in each repository a getting started section. It is not the same thing as a table of content. It's rather like you have the table of content on one side, and then we have the recommended paths to go through if you're new to the environment. And then I say, well, if you want to get started with ZOS, you will probably want to go first to the getting started section in one of the other repositories, namely the repository of Zero Core. And then you go there, and from there you go and step by step. And here you see, by the way, actually what we are about to do next. Also, there is also tutorials like creating a boot disk. How do you do that? It's all nicely documented. So that's good to know. And remember that in each of the repositories, there is this docs folder or directory, and that should enable you to navigate. Now, let's discuss the repositories, and I think it's better to see my slide on this. These are the, I will maximize them too. These are the main repositories, and what you will see is the first one is the initramfs. Initramfs is basically the collection of shell scripts that you can use to build your own version of the ZeroOS kernel. As you will see in the exercise today and Thursday, we will not do that. I'm planning to organize a session on that too, because it's certainly quite interesting for some of you to create your own build and to create your own kernel. It's not at all difficult, it's very easy, but for now it's not important to show you how to do that. But it shows you, well, what you will see in there is the configuration you need to do that. Then probably one of the more important one is the Zero Core. Zero Core is also the name of the init process, or the init process that we are actually created ourselves. That's really the like the, what's the name in what's the name again in Ubuntu of the, I forgot about init d. No, what's the name? I just no, the boot process, the first process that starts.
Init, yes, it's init.
Yeah, so that's the one. Sorry, what did you say?
Init.
Yeah, the init. Yeah, sorry. Yeah, so this is our replacement. That's where we implement everything, and that's also where we also implement all the commands that Zero Core can understand. What I mean with commands is you don't have a shell. You cannot go to the ZeroOS and have a bash shell and do things. It doesn't work like that. It's receiving commands through Redis, And okay, you will not send messages to Redis yourself. You could do that, of course, but we provide both a Go client and a Python client, as I will demo in a moment, to interact with the ZeroS node. For instance, creating disks, doing networking, managing containers. Everything can be done through these Python clients. Huh? Then we have something we call Zero File System or Zero FS. It's basically a fused file system for ZeroS. It's quite important. It can be used for many things. It's a required component, and it comes standard when you deploy ZeroS. It's a required component for running containers. It's basically, well, it's a fused system, meaning it mounts basically disks that the containers see on ZeroS through a concept we call flists, and we will discuss that later. All comes down to that the actual files, think about a workload, for instance, in a container, I don't know, a CRM system. Well, all the software, all the bits and bytes you need to run that workload in that container should not be copied onto the ZeroS node at all. What actually happens is that you point to a flist, and a flist is basically a metadata file. It's basically a database that contains pointers, so like the directory names and the file names, the metadata, and then has pointers based on hash values to actual files that need to get downloaded when you need them. So things get downloaded just in time by the fused file system, ZeroFS, and that's a very important thing. And one of the nice things with it is that, for instance, the images that you typically require for running a container, you don't need to download them. They are also very small. The actual image, so the flist file, as we call it, is because it's just a database containing pointers to actual files, is a very simple and a very small thing. Zero disk, it's quite simple. Zero disk is what I showed you on the picture. It's the collection of all the components for enabling the block storage. And the zero disk repository is basically the repository where we maintain all the code for doing actually that. And I repeat, in every of these repositories, there is documentation specific to that. The Zero Orchestrator, as I already explained, is the repository where we implement all the code for the orchestrator. So the orchestrator is this thing that you need to talk to through the RESTful API to basically manage the ZeroS cluster. And that's what this repository is all about. And again, there is a Python client for that, which I will demo in one of the next sessions. Zero Hub is quite interesting also because I will you will be using it quite often. It's basically the equivalent of what you would call the Docker Hub. You get the point there. At some point you will create your own containers, your own images, and you can then upload your image for others to use. And of course, that's also the place where we will share our official images, list files basically, for creating or running and hosting workloads. We'll discuss that at length in the next session, where in this session where we start to play with containers. Yeah, good. Let's do a demo. Let's boot a ZeroS on VirtualBox and see how that works. Now, as you will see, I have 3 slides on this. The first slide is about the ZeroS Bootstrap service, and that's certainly the first thing you need to understand what this is all about. I will open it now. It is basically this. It's basically the thing that saves you from creating and from compiling your own kernel. So once again, you can do so, but and if you love to do so, it's also nicely documented on how to do that. so we should be able to do so. But you don't need to, because what you have with the ZeroOS Bootstrap service, and it's a website, it's a publicly available open website. It's a place where you basically can download the latest releases. And you'll always see, this is really the kernels, the FE files. And each time with several flavors, we'll discuss that later, where we show, well, what you see here is for each of the, like this one is the most important one, I think, the ZeroOS Master FE. So this is basically the version of the kernel in the master branch in the repository. And what I mean with repository, it's well, not a home repository, but the repository where we keep track of this one, the init ramfs. So there we will compile them. Good, but the master branch version. So actually the most recent version is there. We have all kinds of other versions. You don't need to check them, but we always show you then from here, like you can download it. That's what I do here. I'm downloading the most recent, most recent build of that version. But also it shows you below all the kernel builds. So this list is like per version the most recent build. Here you see all the builds. That's interesting. And then I will not discuss this here. There are all kinds of URLs. I'll use one and explain one in my documentation if you go to the slides. Here. What you typically will do at the command prompt is, well, let me do it. Let me take a command prompt here, like this. What you typically do at the command prompt is, maybe I should put it aside like this. I have two screens large enough, right? So what you typically do, you specify, yeah, not like this, of course. You specify the branch you want to now have. So that's certainly the exercise I'd love for you to do. You specify the branch. You specify a zero-tier network. Now that's interesting because we didn't show you yet. So I'll go to my zero-tier network. So that's something you will need to do yourself. Go to zero-tier, get yourself an account, and make sure you create a network. In my case, I have a network here, happy_Bardeen. I can go to it, and the network has an ID. So you will want to create your own network. In my network, as you will see, and I will show you in a minute, I have several machines online, and we will use that in a moment to add machines. Okay, but it's this ID that I just copied that you need to keep track of. So if you go back to the slides, so you take this thing here, like this, copy, ups, and then of course you replace the network and explain exactly what will happen. So in my zero-tier, take the network, it's here in the URL, copy it, like this, very simple. And then basically download, as shown here in the slide, download, yeah, the full string. Yeah, you get the point. So what this does is it will download not a kernel, but an ISO file with the bootloader, everything, to basically use in a virtual machine. So I'm downloading, I will do it now, I'll download an image, an ISO image that is aware and that will automatically, when you boot it, connect to my zero-tier network. I'll show you that in a minute. So I'm not sure where I am here. So I have a new file. So it is here, just got downloaded. So that's the first thing you need to do. And then, well, clearly, it's quite simple. You start VirtualBox. let me use it. Like this. And let's create a new machine. Call it the EAP machine. Whatever, huh? What's in the name? We use, well, you specify Linux, Ubuntu, whatever. It's, well, 0OS is not yet in the list. So we take the thing which is probably most close. We take Ubuntu. And then you basically accept all defaults, nothing special, all defaults. And what is interesting for the exercise is that I always love to add some disks also, because we'll use them in the demo. So we go to SATA and we create or add a few disks, create new disk. Again, accept all defaults. Same, let's do this 3 times. No, not here, sorry, here. Add disk, create a new disk, defaults is okay. You need to rename, otherwise it will not work for the second time. And well, not 2 is enough. Let's do with 2, should be fine for the exercise, okay? Okay, that's it. And then we need to boot it. I always try to start to boot it like this. If it fails, I know what to do. It fails, so you will have the same thing. Good to know.
Sorry, ik kan Saloon niet tussen je muziek vinden.
Wait, Siri thought I was talking to her. Okay. What I will do, I need to go to settings, of course.
Yes.
And there you need to go to storage also. Remember that.
Yeah.
And then you go to
empties. Select.
You click the empty one.
Yeah.
And here on this disk thing here, you select that you want to download a virtual disk. So I choose to download, I think it was this one. But this is the one of yesterday. Let's take the one of yesterday. Doesn't matter too much. It's the same thing, same network, so it's okay. Okay, and now we can boot. And it's simple, booting. You will end up basically, and it's the second one I have running on my machine. I'm basically running also, you see, I'm currently running three nodes, 3 0OS nodes in virtual machine. So it's easy for you to do so, the same thing. Okay? Don't do that. Let it do. While it is running, it goes quite fast, so we can wait for it. And now it will start to check the network. And check this, I'll put this here. Go to zero-tier here, to my zero-tier network. I'll do a refresh also. Yeah, you scroll down. And it's always nice to see only the online OSs, this. Vale. Yeah, there it is. And you see, a new machine is requesting access here. And just see that currently it says okay, but there is no IP address yet. It doesn't have IP address yet. So you see here, there's nothing. So let's just authorize like this, Chaka. I always love to give it a name like EAP, whatever. And what should happen now, we authorized, automatically you should see appear an IP address here. You see, it's coming through. Also there, it should show up in a minute. Did I? Ah, okay. Okay, it's this one. Yeah, this one. So this is the IP, which is nice. So I got an IP address, and you see the same IP address here in your zero-tier, and you see there. Okay, so that's basically the first step. So you're fine. So your 0OS is active, and the nice thing about zero-tier is that what I did on my machine, in my Mac, for instance, I also installed the zero-tier client, and with my Mac, I'm connected to the same network. So also my Mac has an IP range in the same thing. But what I also did, I'm running a machine on DoConf in Dubai. Basically, I have a machine in Dubai, and this is this machine. Let's go to that machine. This is my This is my machine in Dubai, and this machine in Dubai. Let me do a Ctrl Z here. This machine in Dubai is also in the same network. So you can see it here in 0 tier. The Eve machine is on that IP address. And the EAP machine is on that IP address. So the first thing you can do, of course, is basically do a ping, like ping the IP address. Okay, see? So they see each other. The same thing goes, for instance, of course, for my my own host. We see it. So there is no need to do any port forwarding in VirtualBox because it's through this software-defined network that 0 tier provides us that we have access to. Now the Python client. In the documentation, I give 2 examples of code you can write. So the code is basically here. The first thing you need to do is install. You need to install the client, and that's what you do. That's simple what you do. And this machine that I have here in Dubai, there is nothing special about this machine. I only did install the Python client. That's it. Nothing else. This Python client. And by doing so, I can call the IPython tree, the interactive shell. Not this one. Yeah, the IPython tree, of course. I'm in the wrong machine, this machine. And by the way, I learned a trick today from Jan. There's another way to do so. What I need to do is FG. People will laugh at me, but I'm still learning to work with Linux sometimes. So basically, I already had a session open and I'm using it. So what you will do then, and check the code in the example, and also see the documentation. There's more documentation. So you typically need to import the space, and then the next step is what you see here. You need to create the client, and then the only parameter it needs is the IP address of the node. And of course, this IP address, as you know, was this one. Copy, chaka, put it there. Very simple. Okay. Okay, voila. And then you do cl.ping, same exercise, and you'll get the pop. So that's the basic thing. What I did as an example, I included some nice working code example. This one, let's use it. The first one is that you, of course, have multiple things you can do. You can check the file system. So we are checking now the file system, and this is basically showing the file system, basically the boot disk. It is showing the boot disk and everything that got installed. More importantly, what you will want to see is you want to have a list of all the disks. And remember, I have added 2 disks. So what we should see now is a list of 3 disks, basically. The first one is the boot disks, SDA, and then you have 2 other disks that I just added, the B and the C. Yeah? They are all there, C. Now, what I show you in the code is very simple. It's like, let's, just for code purposes, do this. So let's get the name of disk 1, and let's get the name of disk 2. This simply the B and C, right? I'm also going to create a small, like this, it's a small, simple code. And it's almost too simple to show. But I invite you to play with it. You could also create partition tables if you want to first. I did skip that step. Then I create this. And what I'm actually going to do, that's the important step. I'm going to create a rate 1 or a rate 0. I'm going to create a rate 0, and let's call it my data disks. My data disk. Whatever, you give it a label. You specify this devices thing that I just created. So I'm specifying these 2 disks, so the def SDB and def SDC. And I'm then specify the data and the metadata. So I specify rate 0 for the data and rate 1 for the metadata. So it's basically a striped version. Huh? And I'm basically formatting it with the BetterFS file system. That's it. Voila. So now what I will have is I forgot to add one simple comment in my example code. Yeah, there it is. What I can do, this command, you can also, and that's interesting for those that want to play, you can always send, you use the system namespace, and then you can send whatever whatever comments you would want to send. And here you nicely see that my disk got mounted successfully. Now, wait, I need to mount it first, of course. So I can mount it, that's what I could do. Let's create first a directory. Let's also create a directory, of course. I create a my directory. Yeah, so if I do the, and in this directory, I will mount, that's what you see here, the device name. Yeah, this will not work, of course. Yeah, I need to, well, I could mount one of my, this will not work. I need to review. This is, I cannot mount, I cannot mount, I think, devices, device name. Yeah, you see my point here. I made a mistake in my example code because when I will do this, of course, how did I do that before?
Can we mount devices?
Yeah, let's do that. That's what I think.
No?
Yeah, I hope. Sorry for the confusion. Voilà, copy.
Sure.
Yeah, no, not sure.
Makes sense.
No.
Just use one device.
Only one.
I could take one, of course, but that's certainly not what I want to achieve. So I'm missing a point here. But let's make sure that I correct that for the session on Thursday. So this should work. Device name 1. Yeah, and then of course, yeah, you can always create a file and do things. And well, the point is that this well, not my striped disk, but my first disk is nicely attached. You can upload the file, and that's what I show you here. So voila, I think I need to make sure that this example is better documented because there's a mistake in my example. I will not fix it now. The point is that this is, for most of you, more than enough to get you started. You I think have a lot, and even more, some of you knowledge than me on this, so you will be able to create nice things. To start to basically introduce the next session, what I really want you to do, apart from trying what I just showed you, is I want you to create a JumpScale 9 Docker container. And the JumpScale 9 Docker container is in another GitHub organization, in another repository also. It's in the JumpScale organization under developer, and it's also there fully documented. So here you have the documentation on how to install JumpScale 9 Docker container with all the steps. Huh? Now, it's not difficult. There are a few steps. They almost fit one page. what I did in the documentation, for your convenience, I included view full screen. What I did on my machine, sorry. So these are basically the steps that you need to do to create a Docker container that will run JumpScale 9. This is what we use ourselves, all of us here, to do the tests. Basically, what we will do with it, most importantly, it's not necessarily really for the next session, but it's very important for the session on next Tuesday. It's a session about creating and working with the orchestrator. We will basically deploy the orchestrator in the Docker container. And we will basically run the full ZeroS cluster that you will be working with from indeed the Docker container. And all interactions will be done from there. And what I'm doing here is basically specifying a specific branch. And I'm specifying also the zero-tier network ID, so we recognize mine. And I'm also mentioning here, that's important for you to know, a zero-tier token. Of course, I should not put this on a slide, because that is my token. And that's what exactly in the zero-tier network, if you check it out. You can go to account. And when you go to account, you can create a token. And that's basically an API token that then the Azure Service Server basically will use to do all kinds of deployments and authorizations automatically. So you don't have to authorize manually a node, but it will then be the orchestrator that will see new nodes and will accept them automatically for you. And that's basically where it needs the API access token for. Good. Voila. This is basically the first session to get this started. As a follow-up, once again, I really invite you to take a virtual box, deploy a ZeroS, exactly the way I showed you, install the Python client on your local machine if you want to, and interact through basically the model. And I didn't really show you, but the model itself is also nicely documented. So what you typically do, you go to docs, remember, then you say, well, I'm going to the getting started with ZeroS. Say, oh, you will probably want to start with the zero core, and there you will want to start with interacting with ZeroS. And then you say, well, what are the available comments? Well, we need to fix this. This is not correct. So available comments. And then the Python client example is there. So there we have other examples. I will make sure as a follow-up that this one is correct. By the way, it's not that because it doesn't work, it's not an issue. What you can always do, just for your information, you can always go to docs. You can always go to interacting yourself manually. And there you see the comments. That's a folder. And in the folder, then you see the multiple domains or whatever you will, namespaces. So I was using file system, remember? And then in file system, you see the open, the exists, and each time the comments that you will send, the arguments. Of one of the ones I use, for instance, remember for formatting the disk, the BetterFS, for creating it. And here you see what I used, the data profile and the metadata profile. Remember these two arguments. And here you see the arguments I used. I used rate 0 for the data and rate 1 for the metadata profile. See? So it's also all very nicely documented. I also used at some point in time the things under system. Well, system maps to core here. You basically need to know. And we use the ping first, that's the very first one. And then we use system, core.system. And it basically allows you to send any comment to the environment. And here you see examples. You could do ls -root. There is even an example in the documentation. You can already check if you want to, under JumpScale, that shows you how you even would how you would even create an how you would even install the SSH daemon. It's not here. It's well, it is here. Yeah, it even shows you how to install the SSH daemon, start it, and get things with it. So it's just nice examples for you to play with. Yeah? Voilà. This is my kickoff session. Thank you very much for listening. I'd like to hear feedback, questions. What should we do different? Whatever. And remember, the next session is a session where we will have certainly more interaction because you will have questions yourself. So here on the table, some things that you want to know, missed.
Okay, thank you.
I see Serge. I see. Did you enjoy? Was it useful for you? Dima is also there.
We're here, but we didn't start from the beginning. Yeah, it's useful as a first overview. Is there anything that is planned for the next for continued sessions?
Yeah, it's in the slides. I will share the slides with you immediately after the session. So this is the schedule for all next sessions. And basically what we will do on Thursday, we will play more extensively. And when I say we, I mean we, so you, with the APIs. Yeah, not yet the orchestrator, but really
Just maybe a stupid question. Why are you using VirtualBox for the sandboxes?
You want to know why I was using VirtualBox, or you want to know where to get it?
No, I know where to get it.
Yeah.
I wonder why.
Oh.
That's why.
Oh, there is no really a reason. To be honest, it's rather personal because.
Yeah, I see. It's a matter of taste. Okay, good.
Yeah, because as you will see in the documentation, by the way, if you go to docs on Zero Core, and there is a folder booting, and then you go to booting, and then you'll see that you could also create a USB and do it physically on a machine that you have around. You could do it on Packet.net, on OVH. You could create an isofay yourself. You could even do it with QEMU if you want to. Huh? The USB documentation is quite okay also, because it explains you both how to do it with a bootloader and without a bootloader. So there are certainly other options too, or for you. So do whatever. All of them should work. And if you have an issue with any of them, contact us. And we need to support you, and we need to fix whatever need to be fixed. Herbert, was it useful for you? Herbert?
Yeah, sexy feels very cool.
Did you work the word sexy?
Yeah.
Okay.
You're sexy.
Yeah, I love you too, Herbert. I love you too a lot. And it's all being recorded, so it can be used against us.
Should be off record.
But we can always cut it, of course. Nicola, was it useful for you?
Yes, of course.
Yeah. And Alexander and Nicolas, I think for you it could have gone a little bit quicker because you are such a fast learners, but I guess that you are already trying it yourself.
Yes, indeed, John. Yes, indeed. Yes.
That's how you guys are.
Nice.
Excellent. Good. Somebody else? Peter, Ahmed, any feedback?
Yeah, no? I already tested it before.
Ah, excellent, excellent.
Installing the environments.
Yeah. Okay. Good. Let me make sure that I know everybody who has who attended, and I'll follow up with you in Telegram. So I create a Telegram group. We already have a Telegram group, and let's leverage that. I will make sure that everybody has access to the Telegram group, and that we then share the slides, and discuss whatever question we have going forward. I'm really excited to work with you, and looking forward to Thursday, 10 o'clock. See you then. Bye-bye.
Yeah, thank you. Yves.
Thank you. Thank you.
Bye bye.
Bye.
Bye bye.
Goodbye.
Hola. First session, eh? Let's.
Congratulations.
Yeah.
Yeah, good.
Yeah, it's
I've done a great job.
recording.